So when we take a derivative, all that we do is we just take the exponent, move it down, multiply it, and we get our derivative. Great. But what happens when it's something different like this? You got 5 to the x to the squared. Then what do? That's what we're talking about today. So what we're doing today is a rule they can only use when a function is the exponent. So you have some number as your base, and then an actual equation is your exponent. For instance, you might have 5 to the x squared power. You might have 6 to the negative 3x cubed power, so on and so forth, okay? An actual equation, such as f of x, are the exponent. And we call this the exponent rule. Now here's how it works. When you take the derivative, what you do is, let's say our equation is 5 to the x to the squared, okay? Well, the derivative would then be, well, a to the f of x, so it's going to stay the same, 5 to the x squared, times ln of a. Ln of your base is what that is. So ln of 5 times the derivative of whatever the exponent is, which would be 2x. That is what you would get if you went through and multiplied everything out and used the, what is it called? The difference quotient rule. Maybe you remember the difference quotient? It's f of x plus h minus f of x all over h. Okay. All right, some of you remember that. Some of you remember not liking that. That's fine. Okay. If you went through and used this, that is what you would end up getting. Let's try another problem. All right, here's 3 problems. Let's give them a try real quick. So over here, we have 7 to the x to the 9th power. Well, if we follow this pattern up here, the answer is going to be 7x to the 9th times ln of a, so ln of 7, times the derivative of x to the 9th, which is 9x to the 8th power. And you're done. You can leave it just like that. You don't have to do anything else, okay? Let's try this one. The derivative of h. Well, we're going to have a, f to the x. E is just numbers, like 3 point something. I can't remember the exact. E is a number, okay? So e to the 3x to the 4th times the ln of e equals 1. So whenever there's an e there, you kind of get to skip this step because the ln of e is 1. So basically 1 times whatever it is, it doesn't matter. So all I need to now do is just write the derivative, which is 12x cubed, just like that. And that's my h prime of x. Let's try this one. I prime of x. Well, we've got e of x. Then we have to take the derivative of x, which is just 1. Then ln of e. Oh, hey, ln of e is just 1. 1 times 1, that's just 1. So I prime of x is just e to the x. The derivative is the same thing as the actual function. That is an anomaly. That's the only time that you'll ever get that. Okay? Cool beans. All right, here are 2 more problems. I want you to pause the video and give these 2 a quick try, okay? On your mark, get set, go. All right, you should have paused the video. You should have your answer by now. Let's talk about what the answer is, okay? So, if we're following our pattern up here, I'm going to have h prime of x equals 4 times e to the 3x squared times, I don't have to worry about an ln, okay? Because ln of e is 1. But I do have to worry about the derivative here, which is 6 times x, okay? That is the first part of the derivative. Now I have to worry about the second part. Plus 7x cubed ln of 7 times the derivative of x cubed is 3x squared. That is an insanely long derivative. Okay, we started off with a super short problem, ended up with an insanely long problem for the derivative. Scary. All right, let's try this one over here. We want to find g prime. g prime of x. Again, you should already have the answer. You should have paused the video. You should have the answer by now. Let's do it. Well, this is a super easy one. That's just 8x. Okay, x is not in the exponent. All of this is just x squared. You know how to take the derivative of x squared. It's going to give us 8x. Okay? Plus 3 times, let's see here, we've got e to the x to the 4th times 4x cubed. Okay, because that's the derivative of that, of x to the 4th. We don't have to worry about the ln. Plus, we've got 8 2x to the 5th times the ln of 8 times the derivative of the top, which is 10x to the 4th. Ugh, that's another long one.